So the distance between a point and a line, this is a 2D diagram, and clearly this is in 3 dimensions. There's my line, and there's my point P. Now I'm going to say my distance is the perpendicular distance. I think we understand that. So that's got to be a perpendicular line, and I'm really, really interested in what this point Q is. If I can find point Q, then all I'm thinking of is I've got a vector and I want to find the magnitude of the vector between P and Q. So I'm going to find PQ, which is probably going to be Q minus P, isn't it? Because here's point P and here's point Q, so PQ is Q minus P. Doesn't really matter which way we go there, we'll just do it so that it's easiest on the maths. Okay, point P is easy, because there's point P. We're finding Q. Let's just think about that, because this point Q is the point X, Y, Z. Yeah, and what's X? X is, we're going to be thinking about this equation there. So it's going to be 4 minus lambda. Y is going to be 0 plus lambda. 2 plus 2 lambda. That's my X, Y, Z. So that's actually point Q. So there's my Q, there's my P, and I'm going to do the vector QP, which is going to be Q minus PQ. So it's 4 minus lambda minus 2, which is going to be okay, the next one is going to be 0 plus lambda subtract my 1, which is lambda minus 1. And my next one is going to be 2 plus 2 lambda minus my 3, which will be, there we go, that's lambda. Okay. And interestingly enough, this PQ vector has to be perpendicular to the direction vector of the line. And if they're perpendicular, the dot product is going to be 0. So I have a direction vector. So it's going to be minus 1, 1, 2. And 6 minus lambda dot. So let's do that. Lambda minus 6 plus lambda minus 1 plus 2 times, and that equals 0. That is going to get you, no, it's a bit nasty, but that's what it is. Lambda is 1.5. Now, I said before, this vector is the vector QP, or PQ, which is this thing here. Yeah, there it is there. So there's my lambda. All I'm going to do is to go here that this vector, PQ, is, well, what's 6 minus 1.5? And 1.5 minus 1. 2 times 1.5 is 3. 3 minus 1 is 2. Hey, that is this vector here. That's the distance. How do I find how big that thing is? 4.5 squared plus. And if you do that, guess what you get? 7 root 2 on 2. Okay. That was nice. We just used some fundamental principles there and